Okay. So we're going to start off where we left off on Monday. You will need your Z tables. So you're welcome. You're welcome. You're welcome. You're welcome. Welcome. All right. So on Monday, we started looking at it. We were looking at figuring out what the Z-scores were, finding the probabilities that go along with those, and doing some calculations of those. So let's start with that. So in this problem, we have our mean and our standard deviation. And they want to know what percentage of students have exceeded your score of 644. So if you don't recognize this, this is the wonderful SATs. And they actually regularly change how they do the calculations. So the SATs is designed to have a mean of 400 and a standard deviation of 100. That's literally what it's designed to do. So if they start doing the test and they're noticing that the average score or the mean is moving from 400, they adjust things to keep it there. So your scores that you get like 5-6 years down the road are not comparable to what the scores would be then, because they will adjust things to keep that standardized. So when we're looking for our Z-score, what's the formula for it?
Or no, sorry, it's standard deviation is on the bottom.
Yep.
X minus the mean.
Yep. And X minus the mean. So I need 3 pieces of information to do this. I need my X, I need my mean, and I need my standard deviation. So what is the X in this problem? 644. What is the standard or the mean? And my standard deviation? 100. All right. So let's find my Z-score. That's not what I wanted. All right, so my Z-score is 244 or 2.44. Oh, and I knew I forgot something. I forgot the little note part, the little sticky notes. So we're looking at somewhere over here. And we wanted above or below that? Exceed it. So we want this section over here. All right. So let's look at our Z table. And let's find 2.44. And we should get 0.9927. So just a quick reminder. So we go to 2.44 or 2.4. And we go over to 2.44. And then that's the number I want. All right. Is that the answer? No, because the percent is always from the left over. So we want the opposite, the complement to that. So we have to do 1 minus that. So the answer that we want is 0.0073. So they're
You get that again? The 0.0070.
1 minus 0.9927. We wanted the complements of it.
Okay.
So, all right. Okay. Good. What happens if I want to do the opposite of it? Say I wanted to find what score I would need on the SAT to score in the 95th percentile, which means I beat 95% of all the people that took it. Okay. So in this case, I don't know the X. But in any kind of equation, we only can have one variable that we need to find, right? So if we look at this one, if I don't know the X, that means I would have to know the Z. As long as I know the Z, I can find the X. Okay. So I'll rewrite the formula. In this problem, we've got our mean of 28 and our standard deviation of 2.5. And we're looking for the X. But it gives me, it says that the area to its right is 0.6700. So that means that somewhere over here, so that is 0.6700. Because that's to the right, correct? Okay. So what's on this side? No. So they're not good. That's not a Z, right? That's not my Z score. Otherwise, you'd be correct. That's a percent. So what's the whole percent? Is going to be 1, right? So I have to do 1 minus it to get the other side. So 0.3300 is on that side. Okay. No.
Oh, so you're minusing 1 minus 6 point.
Right, because we need to find our
Z.
Z score, right? And our Z score is always from the left over. So I'm not going to look up the 0.6700 on my Z score because that's going to give me the right side, and I don't want the right side. I need the left side. So I needed to find the left number to look for. So now on my Z table, we're not looking, this is not a Z score. This is a percent. This is in the middle. So we're going to look in the middle here and find 0.3300. No, so you looked at Z. That's not a Z score. That's the percent in the middle. So in that middle box, you're looking for 0.3300. Okay, that's our percent. So we're going backwards. Yes. Yes. So look in here, find 0.3300.
Oh, I found it.
So on this one, it's right there. So that's negative 0.44. So it's negative 0.44 is my Z. That's the complement of what they gave me. Yes. Yes. Yep. All right. So now I know my Z, I know my mean, and I know my standard deviation. So 0.44 equals x minus 28 over 2.5. We're using our z-score table, our z-score formula.
Okay, so how did your X become your Z?
My x isn't my z. My x is there.
But you just wrote your Z equals negative 0.44.
Right. I don't have my x in this problem. They didn't give me my x. My x is a question mark. They don't have it. I need to find it. I'm going backwards. So typically what you would have done is your final answer would have been that. I'd have asked you what percentage is above this, whatever number it is. So, and you would have told me 0.6700.
Okay.
This problem is asking you to go backwards. It's asking you to find what that number is.
Okay, so I got that and then you minus it from
Right, so we got that, and then we looked at this table to find my z-score. So my z-score is negative 0.44. Now I need to use that to find my x. Because that's still z, not x. We have to do a little bit of algebra. Very small amount. So how do we get rid of division? Multiplication. So I have to multiply by 2.5 first. Okay. So do you have the number for me? Negative 1.1. Thank you. And then we add the 28. And that's my answer. Go ahead, ask.
So you take. I'm confused on how you did all of that.
How I did, you don't know how I got the negative 0.44?
Yes, that I understand.
Okay, so this is my formula. Z equals the x minus mean over standard deviation. That's the same formula we've been using.
So your X is what?
X is x. We don't know. That's what we're looking for.
So what do you do? Take 28. What do you do? Take your 28 divided by 2.5?
No,
That's what I'm confused on.
I know. That's what I'm saying. We have to do a little bit of algebra.
Okay.
To get rid of the 2.5 on the bottom, you have to do the opposite of it. Since it's division, you have to multiply both sides by 2.5. So I multiplied 0.44 by 2.5. I got negative 1.1.
Times 2.5.
Yes.
1.1.
Negative 1.1 equals x minus 28
Where do you get the?
because it was negative 0.44. It was a negative 0.44. You don't have to multiply it again. It's just going to come out to be a negative answer. It's negative 1.1.
Wait. Oh, okay.
And then we're adding the 28. Yes, because we want to get rid of subtraction by adding. You have to get rid of subtraction by addition. That's a little bit of algebra. And that's pretty much the extent of all the algebra we're going to use in this class.
And then you add 28.
Yes, because I want to, what plus or what minus 28 is going to give you negative 1.1? So you have to add 28 to both sides. And you get 26.9. And now if we did the exact problem the other direction, use this 26.9, we would get 0.6700.
So
Okay, I'm going to do another one. Follow along with the next one. Your problem isn't stats. Your problem is algebra at this point.
yeah, and I sucked at it.
Unfortunately, this is the only piece of algebra you're going to need to know. Or I can give you another equation you have to memorize. Your choice.
Another equation.
Okay, I'll give that to you in a second. All right. What temperature represents the 90th percentile? So percentile means that's over, right? That's on the left. So I'm looking for 90th percentile. I'm given, this is that's 90, right? Okay, good. Go backwards. Find me my Z. Here's your other formula. Is it minus Z? Yes. It's Z times standard deviation plus mean. Yep. That's how you find your X. Mhm. Yeah. I don't think it's exactly on there. You get close. Where's 90? Yeah, you can get close to it, but not exact. Maybe. All right. What's my mean? And my standard deviation. We're looking for my X. So we've got 90 there. So now if you look at your Z table, we're on the positive side because it's above 50. And we're looking for 0.9000. And what you'll find is you won't find it. You'll have this. You'll have those two. Which one's closer to 0.9000? That's closer. I know everybody always goes, oh, 0.901, 0.8997 is closer than the other one. So that's what we're going to want to use for our Z. So our Z in this case is 1.1 or 1.28. Okay. So multiply by the 0.73. And then subtract the 98.6. Oh, sorry, add the 98.6. Why did I put plus there? Or if you want to remember two formulas, you can use the top one. You always stay with what was there. So in this case, they had 2 decimal places, so 2 decimal places. So 99.53. Use the first formula that I gave you. Use the top formula. You don't have to do the algebra. So Z 1.28 times 0.73 plus 98.6. That's the formula I gave you. And that eliminates the algebra. And you should have gotten 99.53. Okay, so we can go either direction. So that this actually means this is actual scientific data. This is actual numbers. That 10% of the population actually has a temperature higher than 99 degrees. The average temperature is higher. You have people that have lower temperatures. 98.6 is just the mean. That's not what everybody's temperature is at. So, how many of you remember what happened during COVID when you had to go in and out of buildings? Had to be scanned, right? Stuck the little thermometer thing at your head. Anybody remember what the temperature was that they denied you service? It was 100 degrees. Although those things were horrible because it kept telling me I was like at 95, 96 degrees. It was like, they were bad. But it was 100 degrees. Okay, so that's your X. I'm giving you your X. What percentage of the population would have been denied entry into those buildings? So X is 100. I want my percent. So we're going the other direction now. So I'm giving you your X. You already have your mean. You already have your standard deviation. I'm telling you your X is 100. And I want higher than 100. What percentage of the population has a normal temperature that is higher than 100 degrees? I know the answer is not 1.9. That might be the z-score, but that's not the answer. Yeah.
If the z-score is 1.9178, do you want us to round to?
Yes, you round.
So it's
2.7%.
My z-score is 1.92. Look up 1.92. 0.9726. I wanted greater than 100, right? So we're going to do 1 minus that. 0.07, oh no, sorry. 0274.
Oh, you gave us the X as 100.
Yes. Yep. Okay. So yeah, like 3% of the population would have been denied just because their temperature was naturally high. Okay. So that's not the norm, but it's can happen. Okay. All right.
Can you leave that for a second?
Yep. Yay. Huh?
a stupid question, but so for the negative side, it's just everything below 50%.
Yes.
That's just everything above 50%.
Yep. Because the 0 is the mean, right in the middle. So that's why it cuts both directions.
So
All right. The last thing we're looking at is
7-4.
Yeah.
Where's that?
1 minus the 0.9726 because I wanted greater than 100. Remember, the z-score is always going to give you the left. I want the right.
Can you go? $192. I'm looking at 192 and it's 0.9719.
No, that's 0.1. That's 9.1. Look at the top of your table. The second column is 0.01.
Oh, I see. Oh, okay.
Okay. So remember this problem? All right. So we did this problem in chapter 7. And we had to use a calculator to determine the answer for this problem. Because it was the way that the calculations were done, we would have to do a bunch of calculations to figure out the answer. So what would be ideal is if we can use what we already know about the Z's table to be able to do this. So most situations, once you get past 30, fall into a normal distribution. Okay, there are exceptions to every rule, but basically, as long as n's over 30, we're good. Now, this problem n won't be over 30, but we're going to assume it's a normal distribution for the essence of this problem. So we can take the binomial experiment problems that we were doing and translate them into our normal distribution and using our z-scores, which makes our lives easier, makes our calculations a lot easier. To do that, what do we need? We need 2 pieces of information. I need to know my mean and my standard deviation. That's the big thing that these problems don't give you off the start. You have to calculate that. Okay, but they give you the information to calculate it, and the calculation is pretty simple to do. So remember, our mean is just n times p. So in this problem, my n, oh, this one, that's right, this problem, they didn't give it to you. So we're going to say our n is 18, because that's, if I remember right, that was the number we started to use. And my p in this case is not 20%. 20% is the people who don't show up, right? So what's the percentage of people that would show up? 80%. So my p is going to be 80%. Because I'm talking about, I want to know how many people are going to show up. So if I sell 18 tickets, I want to know how many people are going to show up to the flight. And remember, my flight only has 15 people, 15 seats. Okay. So I'm going to sell 18 tickets because if I remember right, that was the number we came up with, was the ideal number to sell in this class. So I'm going to sell 18 tickets. I want to know how many people are going to show up. Okay. That's the question. So to show up is 80% of the people should show up based on the information they gave us. 20 people will not show up. That means 80% will show up. So what is the mean? So I'm going to do 18 times 0.8, which is 14.4. That's my mean. My standard deviation is 18 times 0.80 and then times 0.20. Remember, these two numbers right there always add to 1. Yes. It's the complement of it. And again, it should always come out to be 1 when you add those two numbers together. So this comes out to be 1.70. Okay. We good so far? The formula for mean is right here. It's just n times p. And n was 18 and p was 80 or 0.8.
Where's the E and the X?
It's that stands for expected value. Huh? Right. We don't. So mean is always the middle. Okay. So when we talked about this before, so we were talking about expected value. So expected value is what we would expect to happen with this probability, which is in essence what your mean is, because that's the most likely thing to happen. So mean and expected value mean the exact same thing in these situations. That's what the E of X stands for, is it stands for the expected value. That's why we don't need to use that. We can look at it as just mean. Now that we have our mean and our standard deviation, we can in essence do what we were just been doing. So yes. Yeah.
Do you just multiply across 18 times 0.80 times 0.20?
And then take the square root of that, yes. So there's a square root button on the calculator.
Yeah.
A little check mark button.
Yep.
Hit that first.
Okay.
And then type the other ones in and then close the print, then hit equals at the end. And if it doesn't come out right, you need a parenthesis in there somewhere. All right. I want to know how many, like, what's the percent that I'm going to have to kick somebody off the plane? That was the in essence questions of this one. What's the probability that I'm going to have to actually bump somebody? So that means I want greater than 15 people, right? Because that would be when I have to bump somebody off the plane. So can I have 0.1 of a person? No. So my normal distribution is continuous, correct? It's not discrete. This situation is discrete. So we need to have some kind of a correction to make this calculation work. Since we can't, did you get the 0.177? Okay, so bring me your cup.
No, I'll do it later.
Okay. But I need you to focus on what we're doing now and not keep focusing on the 1.7. We'll get the 1.7. It's just a parenthesis issue. So I need to correct to deal with the fact that this is not a discrete calculation. So in my last class I said they, which is because it's a group they. The ones in charge when actually created this originally, they had to standardize things because we could say, okay, well, what's greater than 15? 15.1? Yeah, well, 15.01. Like, where am I going to break that point off? They've chosen a half. Okay. So when we're looking at X is greater than 15, I'm going to use the X value of 15.5. You are always going to be a half on either side of what you're looking at. Okay. So my X value, I'm going to use 15.5 for my calculation. That's going to be the, because that says greater than 15. Okay. Because in essence, what I really want in this problem is only 16, 17, and 18. but I'm not doing it that way in this calculation. So we're going to say greater than is greater than 15 is 15.5. Always use a half. Yes. Yeah. So if it was less than 15, I would do 14.5. Yes. If it was 15 and less, then I would use 15.5 because I want to include the 15. So, all right. So now we got to do our z-score. So 15.5 minus 18 over, not 18. Sorry, not 18. I mean 14.4 over 1.70. And I get 0.65.
Where did the 14.4 come from?
Mean.
Mean.
So I'm here and I wanted greater than it, right? So I went over there. So if I look up my z-score is 0.65. That's that side, correct? I want the other side. So subtract it from 1, 2, 5, 7, 8. And that's the probability that somebody's going to get bumped. So there's about a 26% chance that somebody's going to get bumped. But I remember if we sold less tickets, we might not have a full plane. And if we sold more tickets, there's a better chance of somebody else getting bumped. So that was the number. That was, I remember it came up with 18 was the perfect number to sell. That would balance those two aspects. So we took a problem that we had originally done out and used actually a calculator online to find the final answer because those calculations were too much. And put it into the z-score, which we could easily do out our calculations for. Okay. All right, let's look at this one. So the agency did some work and claimed that 20% of the alumni in the state were aware of the new ad campaign. To validate this claim, the agency developed an office survey or developed a survey of 1,000 alumni in the state, and I found 150 were aware of the campaign. Okay, so we want to know if their ad agency's claim was true, that 20% of the alumni were aware of the new campaign. So I need two pieces of information, right? I need my mean and my standard deviation. But in this case, they don't give me those. So what do they give me? So we did 1,000 people. And my probability should be 0.20. That was the probability that they told. So their claim is that 20% is true. Okay. So my mean, 1,000 times 0.20 is 200. And standard deviation times 0.20 times 0.80. Which is Yeah, actually, the bench is already there. You can already close it.
I know. I get it. It's just,
It comes up with the right answer. I wanted to make sure your calculator's right. All right, so we got 12.65. Here's my standard deviation. All right, find me my z-score. Huh? 12.69. Yes.
Oh, that's good.
I got 12.649 when I did the standard deviation.
Oh, my 9 is 4 9.
Got it. Okay.
4.9, not 6.5.
No, it's 6.5. It's 12.65. So we're testing the claim that 150, right? So my X in this case is 150. Yes. All right. So what do we get for our Z? Yeah. Nine one or 9.5? All right. So it's not even on your sheet, right? So the question didn't want the actual percent. What's the question asking? Is their claim true? Right? Their statement says, assuming the ad agency's claim is true, what is the probability that no more than would know it? It's basically 0, right? Okay. It's not exactly 0. We know it doesn't go to exactly 0, but it's pretty darn close based on even yours going to 3.45 is 0.9998. So we're at 2/10,000ths of a percent right there, or 2/10,000ths right there. So it's going to be a really, really small number. So is their claim true? No. If their claim was true, it'd be a little higher than that. There'd be a possibility of it happening. But in this case, no, their claim isn't true. It is essentially 0. Huh?
It's asking what is the probability.
It did ask what the probability is, and literally the book's answer was it's practically 0. That literally was the answer in the book actually was.
It's practically still a chance.
Oh no, there absolutely is a chance. Are you staking your ad agency's reputation on that chance? Right. And that's the piece that's important. Okay.
As soon as it gets to like 999,
You basically, like, that's why this table only goes to the 3.49, because at that point it's basically nothing. It doesn't exist at that point. So you got 0.0002. So if I look at the website that I was using that has them all,
I think it's 0.004. The inverse is 9996.
so if we look here, it was 3.95, right? 0.00004. So there's a 4 in 100,000 chance that they were correct. Okay. If that was my ad agency, I'm going to say our ad campaign failed and we will work to rectify the situation because we did not hit our 20% claim. So this is where, like, and we're not getting into this right now. We're going to get into this when we get to chapter 9, 10, 11, and those is we can start to use these percentages that we get as answers to actually be able to make claims or determine if a claim is valid or not. We can actually start to say, okay, this is true or this is not true. All right, because if, like in this situation, the chances of that only 150 people would have heard about it if their claim was true is basically non-existent. Okay, if it had come out to be like -2, then yeah, there's a chance. And depending on how that far is, that's what we're going to look at later on to make those claims. Okay. All right, let's look at. All right, try this one. Oh, I didn't switch back over. That's not what I wanted. There we go.
Tell me how
Which one?
to do my square.
Square root.
Yeah.
The parentheses are already there.
So hold on. What did you push?
Second,
Yeah.
that.
This one here.
Yeah, see the little
Okay.
check mark button above it?
Okay.
And then we do 200
Yep.
times 0.08
Okay.
times 0.92.
Okay.
Because those two have to add up to 1.
Okay. Thank you.
Mhm. So 200 times 0.08 is 16. What was the number we just got?
3.84. Rounded.
Okay. What?
Because I did 80%.
Yes, that makes a difference. This is 8%, not 80%. So it's 0.08, not 0.8. Yeah, if 80% people don't show up, that's probably going to be a problem. All right. So now we got to do our z-score. 20 minus 16 over 3.84. So 1.04. And we're looking above that, right? We want more than 20. So look up 1.04 on your Z table. So 0.8508. I wanted more than that. So I'm going to subtract. Okay. Who wants to tell me where my mistake was? There's a mistake on the screen. What? No.
No more than 20 no-shows?
Huh?
Less than, it just says no more than 20.
Oh, okay. So actually, you're right. So actually, that would have actually just been the 0.8508. So you're right, actually. But that actually wasn't the mistake I was looking at. No, that's 0.6. That's 16. That's correct. So you're right. I would want this one because I want no more than. Can I have 14 and a half or 14.1 no-shows? So this is discrete, right? So I have to do the 0.5. I want no more than 20. So it'd be 20.5. Not, this is discrete.
What do you mean?
I can't have a half a person or a half a no-show, right?
But they're-
Huh? I want to do no more than 20 no-shows. Can I have 15 and 0.3 no-shows? Yes or no?
No. But
Right.
Where are you getting this number?
I'm making it up.
Oh, okay, no. but-
Right. So that means this is discrete data. I can have 15 no-shows, I can have 14 no-shows, but the numbers between 14 and 15 mean nothing. Okay? Because it is discrete, I have to do my correction, which is that half. So I don't want to use 20. Since I want no more than 20, I would do 20.5 because I can include the 20. Yeah, that would be the X, and only the X.
So your X would be a
Yes, because I want to include the 20. The way this is done, the way the calculation did, it's not including the 20. Okay, so since it's discrete data, I have to do that correction on it. The correction is a half. So my X needs to be 20.5. That's the mistake I made. So it's 20.5. So it's 4.5 divided by 1.17. Right? Yeah.
But
So-
everything else would be the same.
So 0.8790 is my final answer.
If it said no less than 20.
If it said no less than 20, then I would have done 19.5 and I would have gone the other direction. Because then it would have been no less than means greater than, basically. So, but yes, if it said the restaurant will have less than 20 no-shows, I also would have done a 19.5 because I wasn't including the 20. Because I have to include the 20, I have to go above to include the 20.
Okay, let me now be this. This would be something continuous.
Yeah, it'd be continuous data.
So you just have to decide what.
If it's discrete or continuous. Yeah. If it's discrete, then I have to do that correction, which is the half.
Sounds like it involving people or the with the granular scenarios where it be discrete or is it mostly
It could be like a lot. Unfortunately, with statistics, a lot of things have to do with people.
Yeah.
So, like, that's going to be a lot of cases. Inanimate objects like books and stuff like that would also be discrete, like things you can't cut in half. Like that's the concept. So you have to determine if it's discrete, we need to do that correction. If it's not, then we can do the other one. Correct, because it's not going to be. In essence, this would be time, which is continuous.
76%.
Yes, but that's only because it doesn't display the numbers.
So you say you want that again.
Yeah. Oh yeah, absolutely. It just doesn't display it. That's a display issue more than an act. So the question, so in that essence would be, is there 100 little batteries in your phone that each one of them dies independent of each other? Okay. Or is your battery like a pitcher of water that as you pour it out, it gets less and less? Okay. It's like a pitcher of water, which means that's continuous. It doesn't jump. Okay, if it was all little batteries and that one battery died and there's 100 of them, it's like, okay, I'm now at 99 because one of my batteries died. Like, that'd be a different situation, but that's not the way the batteries are made. So it's more of a stream. All right. So a cell phone manufacturer has developed a new type of battery for its phones. Its inspection testing indicates the population of battery life in days obtained by all batteries of this new type is normally distributed with a mean of 700 days and a standard deviation of 100 days. This is obviously not a cell phone battery for a smartphone. Okay, because there's no smartphone that's lasting 700 days. Well, actually, I guess technically, it could say this is not how long it lasts, it's how long it actually will hold and continue to charge. So I guess that would make sense. All right, so the manufacturer wishes to offer a guarantee, so basically a manufacturer warranty, providing a discount on batteries if the original battery purchase does not exceed the days stated in the guarantee. Yes. So, what should they make their guarantee so that they do not have to replace any more than 5% of the batteries? So, question one, discrete or continuous? This is continuous. And they gave you what? They gave you your mean and your standard deviation. That should be a clue right there. If they give you your mean and your standard deviation, it's going to be continuous. If they're giving you percentages and like numbers and stuff like that, we might go towards that discrete concept. So in this case, they gave me my mean and my standard deviation, so I do not have to calculate those. No, because they gave it to me. Mean, standard deviation. So I have them. Okay, and we're looking for X in this case. We're looking for the battery life, right? They gave me my percent of 5%. So if we look at our bell curve, so this is the mean, that's 700. We're looking, they want to replace batteries, so this is going to be on the low end, right? We're looking on the low end. So we're looking at 5% over here. So that's going to be 0.05, right? Huh? So that's going to be your percent. We now have to find our z-score. So find 0.05. Okay. So you should end up finding that it's 6.4 or 1.65.
1.64.
Yes. Or negative, sorry.
I see it.
Both those are equally distant from the number, right? Okay. In this situation, and this is actually a very specific number that's going to come up a ton in our calculations going forward. You'll actually use 1.645 because it's exactly in the middle. We cut it in half and we do the middle number. So my z is going to be negative 1.645. All right, so find me my x. Huh?
864.
Negative 164.5. You added. You should have subtracted. You found the other direction
Wait, why would I do that?
because it's a negative 100, negative 1.645. My z is a negative. So when I multiply by the 100, I get 164.5 negative. Add the 700 to it. So it's 535.5. Negative 1.645. On your z table, look for 0.05. You're going to find two of them. You're going to find 0.0505 and 0.0495. Right? 0.05. 0.5 is going to be 0. That's your mean. Awesome. Do we find it or no? You're fine. It's less than 30. It's less than 5. That's 0.
Oh, okay, I was looking at.
That's okay. All right. So if you're the manufacturer, how many days are your battery, how many days are you going to tell me your battery lasts?
I didn't know that you were gonna ask a question.
That's okay. I have a few left. How many days am I set my battery to? I'm going to probably do 500. Make my life easy. That's why your extended warranty or your warranties your things always seem to die after the warranty goes out. Why? They figured it out. They calculated it out to figure out exactly when the thing is going to die, and then go, okay, I don't want to have to replace more than this amount of them. So that's the number I'm going to set.
That's fine.
Mm-hmm.
And then they give you-
Mm-hmm. But I will tell you that if they're selling you an extended warranty, they already know that it's going to last through their extended warranty. So, yes. So they already know it's going to last past that, so that they are not losing money. All right. So that's how they do these things. That's where like this concepts that we're looking at really comes into play. Okay. So we're actually starting to get into a point where actually statistics is useful. All right. Your test is on Wednesday. The review test is already up online. It is at the top of your due later or at the bottom of your due within a week. But it's there. So I would practice that. On Monday, we will go over the test, and then on Wednesday is your test.